Hello, everyone, and welcome to this presentation on real-time streaming with Kafka. I'm Tom Stepp, and I work as a software engineer at Google. Today, we'll be diving into the exciting world of streaming with Kafka. This presentation will cover key concepts, practical applications, and best practices for using Kafka with Apache Beam. Here's a quick look at what we'll be covering in today's session. We'll start with an introduction to Kafka, then dive into Beam Kafka I/O, followed by Managed I/O. We'll also discuss the redistribute transform, offset deduplication, active load balancing, Google Managed Kafka, and finally, Kafka best practices. Now, let's begin with a basic introduction to streaming with Kafka. We'll cover the fundamentals of what makes Kafka a powerful tool for real-time data processing. Streaming systems are crucial in today's data-driven world. They're built for a variety of reasons, including processing payment and financial transactions, tracking logistics and automotive fleets, handling sensor data from IoT systems, collecting and reacting to customer interactions in retail, travel, and mobile apps, extracting logs for analysis and fraud detection, and enabling gaming analytics. As you can see, there's a wide range of applications for streaming systems. Kafka plays a crucial role in modern data architectures. It reliably collects, stores, and distributes data streams. It's known for being scalable, fault-tolerant, and durable. Think of Kafka as the intermediary that efficiently connects producers of data to consumers who need that data. In fact, it's one of the most popular open-source stream processing software available today. Let's cover some of Kafka's key concepts. An event is a piece of data with a key, value, timestamp, and metadata. A topic durably stores events and can have many producers and consumers. A partition is a slice of a topic, allowing for scalability and providing event ordering within the partition. Producers are clients that publish events to Kafka, while consumers are clients that read and process events from Kafka. Finally, replication involves storing extra copies of data for fault tolerance. Here we can see all of the core components of the Kafka architecture. You can see the interaction between producers, the Kafka cluster, and consumers. Notice how events are published to topics, which are then consumed by various consumers. Kafka provides various interfaces that allow applications to interact with it. The admin API is used for managing and inspecting the Kafka cluster itself. You could use it to create, delete, or modify topics. The producer API is designed for applications that want to send data into Kafka. If you have a service or application generating data, you would use the producer API to package that data into events and publish them to specific topics in Kafka. The consumer API is for applications that need to read and process the data stored in Kafka topics. Applications that analyze data, store it in a database, or trigger actions based on the data would use the consumer API to subscribe to topics and retrieve the events. We'll now transition to discussing how to integrate Kafka with your Apache Beam pipelines. Here we see the basic code snippet for reading from Kafka. We start with Kafka I/O read, then we set the required configurations, the bootstrap servers, the topic, and we must provide the key deserializer and value deserializer classes. This sets up our Beam pipeline to consume data from the specified Kafka topic. Note that a list of topics may be specified via the plural with topics config instead. We can use several optional configuration settings when reading from Kafka. Any consumer settings can be provided with consumer config updates, such as the consumer group ID. With processing time sets event timestamps. This is just one of several timestamp options available. With read committed restricts the reader to only committed messages, ensuring exactly once semantics. Commit offsets and finalize enables Beam to commit offsets after processing, an alternative to Kafka's auto commit setting, which commits immediately after reading. Finally, without metadata, extracts just the key value pair from the Kafka record, removing its metadata. Now let's look at how to write to Kafka. We begin with Kafka I/O write. Then we set the required configurations with Bootstrap servers, with topic, and with key serializer and with value serializer. We can also include optional producer configurations with update producer properties, as shown here, where we are enabling gzip compression for our messages. Now we're going to shift our focus to managed I/O within Apache Beam, which offers a streamlined approach to working with sources and sinks. Managed I/O simplifies pipeline management for supported sources and sinks. It consists of a single Beam transform that provides a common API for specifying I/O connectors, and a service that provides I/O upgrades independent of the pipeline's Beam version. Dataflow automatically upgrades the managed I/O connectors in your pipeline. This means your pipeline receives security fixes, performance improvements, and bug fixes for these connectors without requiring any code changes. Traditionally, I/O connectors in Apache Beam have distinct APIs, and each connector is configured in a different way. Managed I/O provides a single configuration API that uses key value properties, resulting in simpler and more consistent pipeline code. Dataflow with Managed I/O automatically uses the latest stable connector version for your pipelines. This upgrade occurs for new and replacement streaming jobs, without any code changes. While you build with a specific Beam SDK version, version X in this diagram, Dataflow upgrades the Managed I/O to a more recent version, version Y in the diagram, ensuring the latest improvements and fixes are used. Managed I/O makes Kafka integration extremely simple. You can read from Kafka and write to Kafka as shown, simply providing the key value pairs for your configuration. This streamlined approach greatly simplifies configuring your Kafka connectors with Apache Beam. Let's look at a more concrete example. Here, we're creating the configuration with required properties first, and then we use the managed transform to create the Kafka read. Moving on, we'll now discuss the first of a few ways the Beam runner can help optimize reading from Kafka. First up is the redistribute transform. Let's discuss a common challenge with Kafka and how to address it. The problem is that limited Kafka partitions often result in limited parallelism in data processing. To elaborate further, Beam parallelizes the Kafka source into multiple processing keys, which is derived from the number of partitions. This means that the number of parallel threads processing Kafka input is directly tied to the number of partitions in your topic, potentially causing bottlenecks. The solution is to add parallelism by rekeying inputs through the redistribute transform. This allows us to increase the number of keys in the pipeline without being forced to adjust the number of Kafka partitions. From prior experiences working with customers, this has been a common case. This is because oftentimes the team managing the Kafka cluster is separate from the team building their data processing pipelines. Here, we can see how the redistribute transform is expanded within the Beam pipeline. First, a key is added to create a key value pair. Then, a reshuffle or group by key operation occurs. Finally, the key is removed and the values are extracted. In some cases, data pipelines are not required to perform exactly one semantics at all stages. This may be the case if deduplication is done in a downstream stage of the pipeline or downstream system outside the pipeline. For at least once processing, the pipeline can specify with allow duplicates as part of the read transform. This allows for runner optimization, where redistribute only guarantees all records are processed, allowing a small number of duplicates. This becomes much cheaper than a regular redistribute operation. In the comparison table, we see how a redistribute influences the performance of a Beam pipeline running on Dataflow. This pipeline is reading from Kafka and writing to BigQuery. We first see how redistribute helps scale the pipeline to a much higher throughput, but a consequence of this is the increased cost. When switching to the allow duplicates mode, the throughput improvement remains, but at a much cheaper rate. Now, we're going to discuss the Kafka offset deduplication, which is an upcoming improvement to Kafka reads with Apache Beam. Offset deduplication addresses a key challenge. The redistribute transform, while effective, can be expensive due to latency and costs associated with exactly once processing overheads. Furthermore, the allow duplicates optimization is suitable for at least once processing, but can't be used when exactly once semantics are required. Offset deduplication offers a solution by utilizing Kafka's source metadata, specifically the message offsets, to make the redistribute operation more cost-effective in exactly once mode. You can add offset deduplication to your Kafka read step, but please note this feature is not yet available and is coming soon. Now we'll transition to discussing active load balancing, a feature that optimizes how work is distributed across workers in your Beam pipeline on Dataflow. This is particularly useful when reading from Kafka. Active load balancing redistributes the load by intelligently moving work across different workers. This improves overall resource utilization and pipeline performance. Without active load balancing, a single worker could become a bottleneck, slowing down the whole pipeline. As you can see here, active load balancing moves that work to a new worker to prevent this bottlenecking. For Kafka I/O, this may occur when a partition or group of partitions are assigned to the same worker and have a lot more traffic than the other partitions. Here, we demonstrate the impact of active load balancing not only on performance, but also on cost. In this sample customer pipeline, we can see how work is moved from heavily loaded workers to less loaded workers. This is ensuring that no single worker becomes a bottleneck and overall processing is balanced. As a result, the CPU load on workers is more evenly balanced and the total number of workers stabilizes around 20 instead of scaling up to 120. Before enabling active load balancing on the sample customer pipeline, a single worker or two could build up large backlogs of work to process. After enabling the feature, the work was better distributed. This resulted in lower total backlog and small backlogs for each worker. Active load balancing is done by default now and doesn't require any configuration from the Beam pipeline or Dataflow job. We'll now shift gears to discuss Google Managed Kafka, a fully managed service for Kafka on Google Cloud Platform. Beam pipelines can easily integrate with Google Managed Kafka with minimal changes. Setting up your Beam pipeline and configuration will look almost identical to before, but with the Kafka cluster now on GCP, the authentication might look a little bit different. There are a few authentication parameters that need to be set. As an example, you can see here that we're updating the consumer config with the authentication parameters. This is done with the update consumer properties to apply the authentication config. Beam now has support for an even simpler way to set up authentication for Google Managed Kafka. Instead of the detailed configuration we saw before, you can simply use GCP application default credentials. This authenticates via open authorization protocol, greatly simplifying the process. Finally, we'll discuss some key best practices for using Kafka with Apache Beam. You'll see some common themes from topics we previously discussed. When optimizing for parallelism, it's crucial to understand the limitations. Parallelism is generally constrained by both the number of available workers and the number of keys. In the case of Kafka I/O, this is often directly related to the number of Kafka partitions. Increasing the number of partitions is one approach to increase parallelism, but it's not always feasible. An alternative approach is to use the redistribute transform to rekey inputs into a larger key space. It's highly recommended to specify a limited number of keys for achieving the desired level of parallelism. When working with multiple topics in Kafka, there are a couple of approaches you can take. One option is to create a single instance of the Kafka I/O connector and configure it to read from multiple topics. Then you can filter by topic name within your pipeline to apply different logic for each topic. Alternatively, if you need to read from topics located in different Kafka clusters, your pipeline could include multiple separate Kafka I/O instances. By default, the Kafka I/O connector does not use Kafka offsets to track progress and does not commit offsets back to Kafka. Setting enable auto commit will commit offsets as soon as they are read from Kafka, before any processing done by the runner. This is generally not recommended, as inputs could be lost if there are any retries. If committing offsets from Beam is desired, the best practice is to set commit offsets and finalize, which allows Beam to perform offset commits after its processing. By default, Kafka I/O uses the current processing time to assign the watermark. However, Beam offers additional options for assigning watermarks with log append time or create time. Alternatively, you can set some custom behavior by using the timestamp policy factory. For optimizing performance, you may consider tuning your Kafka client configurations. The max read time setting defaults to 10 seconds. Lowering this value can improve latency and processing, but may also increase resource usage. The other example client settings here can be tuned to help you control the max records or bytes read by the consumers. These best practices are documented with further details at the Google Cloud Kafka Guide. Please take a look if you'd like to review these tips or gather more detailed information. Here's one bonus tip to further enhance your Kafka integration with Apache Beam. Consider using the Kafka schema registry for efficient schema encoding. Instead of sending the full schema with each record, records could contain just the schema ID. And consumers can then perform a lookup or utilize caching to retrieve the schema. One Dataflow customer shared that they achieved 40x performance improvement by implementing this approach. For more details, you can watch the YouTube video on this topic. Thank you very much for attending this talk. I hope this presentation on real-time streaming with Kafka was helpful to you. If you have any questions, please feel free to reach out to me. Thank you.